Hello, dear friends. Our today's problem is problem number 209, minimum size subarray. So we are given an array of nums, and array contains all the positive numbers. And we are given a target as well, target value as well. We need to get a number greater than or equal to the target by adding the numbers that our array contains. So we need to reach this element or greater than this element by adding these elements. But the condition is the numbers we are adding should be forming an subarray. So what is a subarray? Subarray is a contiguous subarray. For example, in contiguous subarray in an array. For example, 2, 3, 1 is a subarray. 3, 1, 2 is a subarray. 1, 2, 4, 3 is a subarray. And even this whole array itself is a subarray of itself. But the thing is, we need the minimum possible numbers to reach this element. For example, if I add 2 plus 3 plus 2 plus 3 plus 1 plus 2, that makes 8, right? But still, I need to require 4 numbers to reach this element. But if I add 4 and 3 only, then I don't need any other element. I can return 4 and 3. 4 plus 3 is 7, and I can return my output is 2. Here, my subarray is my target value is 4, and my subarray is 142, 144. So I can either return this or this. Both of the subarrays are good. So I need only one number to get to my target, right? So, and if there is if the subarray doesn't make my target, I just return 0. For example, if I add all of these numbers 1, 2, 3, 4, 5, 6, 7, 8, that still doesn't make 11, so I return 0. So one simplest way is getting two for loops. One starts from here, and then I continue. Then I'll start adding elements like this, and I will have a count element where my I will have a count element which is counting these counting these elements, like how many elements I have stored, and I will be having a answer where I'm storing these. I know it's a bit confusing, but with two loops you can simply get it. You can simply get it. But our solutions should be big of n, or we can either return it in n log n. But we will be using the most optimal and the easiest approach here today. So that will we will be doing it in big of n. So let's without any confusion, let's dive into the code first. Since my answer should be the minimum possible answer, so for the comparison, I will have my answer as math dot integer dot max value. So I'll compare the maximum value with the other answers, and I'll be storing the minimum possible answer. So also I need a sum to calculate my sum, and also I need, so basically I'm just working like two loops, but I'll be doing the same work in my first loop. For example, I'll be having a left thing, like if I have my left element here, and then I'll start counting these elements, and if wherever my sum reaches, for example, my sum reaches 2 plus 3 plus 1 plus 2, then I will discard this. And I'll start counting from here on. Same thing, it repeats. I'm gonna show you this in the code. Hold on just a second. For int I is equal to 0, I is smaller than nums dot length plus. Okay, let's calculate the sum first. Sum is equal to nums of I, and while I'm saying while my sum is greater than or equal to target. Okay, so I haven't done any algorithm here yet. I'm just putting the conditions what are given to me. I need a sum. I need my answer. I need a sum, and also I'm running a loop where I'm finding the target, right? Okay, so for that I need a left. For the count of the left element, I need a left index counter as well. Left is equal to, let's make it 0 as first, because the indexes, they start from 0, right? Okay, if my sum is greater than or equal to target, what do I need to do? I need to delete the sum. I need to delete the element which is at leftmost possible, and I will need to increment the count of left, and also before that I need to update my answer with math dot minimum answer, or I plus 1 minus left. So why did I do this minus left, for example, and I plus 1? First of all, I plus 1, since my indices are starting from 0, so that's why I need to return I plus 1. But I'm doing minus, for example, here my 4 plus 3 is I'm making my index, but I do not need these elements, right? So if my left is here, then I will delete this left and I'll return these two elements. For example, at the initial state, my left will be at 0, and uh, for example, 2 plus 3 plus 1 plus 2, that makes 8. That's number greater than or equal to my target, right? So those are 4 elements, right? So but the index of this 2 is 3, right? That's why I'm adding 1 in it to make it 4, that I have 4 numbers, and left is 0 right now at my first iteration. So I'll subtract the left. That's just for the indexes, and I'm storing the minimum possible index out of here, right? Also, I'm updating my sum, because for the next possible sum, because I have already reached the number greater than or equal to 7, so I will delete this number from my sum, and I will have this number, and during my next iteration it's going to add this 4 in it, and then the number gets greater than 7, then during my next iteration it's going to add these numbers. So it goes until my uh, array stops, right? So also I'll be increasing the left indexes as well. For example, if left is at 0 at first iteration, then left becomes 1 and 2 and 3, and that's how it's counting my subarrays. But that's basically the whole algorithm is, right? So we just run a loop, get a sum. If the target is greater than, if the sum is greater than equal to target, we store the minimum index, minimum number of elements in my answer, and then I subtract the leftmost index out of it, and then find the other possible sum, and I will also increase the left. But the thing is, if I do not find my answer, if my answer is equal to integer dot value, which means my answer remains my initial value, right? Then I will return 0. If my answer remains integer dot max value, it means there is no answer in it, so I will return only 0. See, if there is no such subarray, return 0. But if I find my answer, else return answer. And let's see, run the code. Compilation error. Yeah, run the code. Oh yeah, she gets accepted. Let's submit it. And it's 100%. It took 1 millisecond and 100% faster than other candidates. So this problem was really simple. I don't know why they made it a medium problem, because there is a learning trick in it. That's why you are doing the work of 2 loops in 1 loop. So just dry run it one more time and try to do it yourself. And if you have any questions, just leave comments down below. Thank you so much.